In this concept video, we're going to be talking about principal values for trigonometric functions. The principal values for trigonometric functions restrict the angle measures that you will get from these inverse trigonometric functions. And let me help you with this by just giving you maybe a little scenario here. So let's say that we know the cosine of an angle is equal to 1/2. And I might ask you this, what is that angle measure? Some of you recognize this 1/2 from the unit circle, and you could do this by hand, just by intuition. You could say, Mr. Valsa, that needs to be 60 degrees. Must be 60 degrees. Cosine of 60 is 1/2. And if you didn't realize that from the unit circle, you might take this approach. You might say, well, let's do the inverse cosine of 1/2, and that will give us an angle. And we can type that in our calculator and see what happens. So we'll do the inverse cosine here of 1 divided by 2. And as long as we're in degree mode, should pop out with 60 degrees. So if you're getting some other value, one of the most often made student mistakes is not changing into degree or radian mode as appropriate. So just hit your mode and then verify you're here in degree mode. So we have verified through a couple different methods here that the inverse cosine of 1/2 is 60. In other words, the value of theta here would need to be 60 degrees. Well, there is some good news and some bad news. The good news is we found a nice value for theta. The bad news is there are other angles that have a cosine of 1/2. So let me type this into the calculator for you. Let me do the cosine. Let's think here. How about cosine of 300? That is also 1/2. Well, it could be 300 degrees. What about the cosine of any coterminal angle with these two? What about 360 plus 60? What about the cosine of 420 degrees? What is that? Well, the terminal sides lie in the same spot, so it would kind of make sense that it's the same thing. So 420 would work. We could add 360 here, so that would be 660. We'll see if that works right. Cosine of 660. So maybe the question is we typed in the inverse cosine of 0.5 or 1/2, and it only spit out one value. I mean, the calculator is not going to give us an infinite number of solutions. Of course, there's an infinite number of coterminal angles with any given angle, and so it would have to just keep running and running and running. We need to restrict that then. We need to for not only for the calculator, but when you graph these inverses, we need to restrict what values we want for the angle. Or you just get a bunch of them. So the thinking here is if we start on the positive x-axis, we want to succinctly find angles that have different values or different cosines and sine and tangent and all that. But we can't utilize many different ones. We have to keep them in either quadrant 1 here and quadrant 2, or maybe quadrant 1 and quadrant 4. We're trying to limit the number of possibilities here. So if you take a look at the cosine, anywhere here the cosine is positive. For instance, if you had an angle here in quadrant 1, that angle's cosine would be positive. Remember from the unit circle, or just when we place a right triangle on the coordinate plane, that cosine is x over r. On the unit circle, of course, r is 1, so that the cosine is just the x value of the point on that terminal side that's on the unit circle. Well, all those points here have a positive x value. As we rotate the angle over here into quadrant 2, you'll notice that we have to go left to get to the point, and therefore the cosine is negative. Funny thing happens though, as we rotate down, we start to repeat values of cosine. We've already got the negative values here. These guys are just kind of repeats. And then as we rotate further around, anything in quadrant 4, the x value is positive, but it would be the same as what we had in quadrant 1. So when we talk about a principal value for cosine, let's say, so we'll do cosine. And let's make this work well. We're going to try to do the inverse cosine here, or arc cosine, I should say, meaning the same thing, just means the inverse. And that principal value will be anywhere here in the first and second quadrant. So if we're talking about angle measures here, what we're talking about is 0 degrees is less than or equal to theta, and that's going to be less than or equal to 180 degrees. And that will cover all the different cosine values, all the positive ones, all the negative ones, and then we would just repeat as we kept going around here in quadrants 3 and 4. So the principal values for inverse cosine are from 0 to 180 degrees. If you're doing this in radians, you would just have 0 to pi. This is different for some of the other ones though, so let's discuss the sine next. So we might ask ourselves, what is the least amount of, or least range of angle measures for which we could cover all the possible values for the sine? And if we look at the coordinate plane here, we'll notice that if our angle is here in the first quadrant, the value of y, which would be sine, sine's y over r, in the unit circle r is 1, so we'll be looking at that value of y, and those are all positive. To get to a point here, you'd have to go right and up. The up part would be the positive value of y. If we keep rotating this direction, we still have positive values, and the y value would be the same as a y value here. So we don't want that repetition, so we can't go any further than this point. Also, if we just started a negative rotation first, all of these values would be negative for y or for sine. So here in quadrant 1 we have the positive values for sine. Here in quadrant 4 we have the negative values for sine, and these guys are just kind of repeats. And then of course as you were to go around even more, if you were finding coterminal angles, you just get more repetition, and we are trying to get away from that. So for the inverse sine, the arc sine here, that is going to be negative 90 less than or equal to theta less than or equal to positive 90. In other words, the range of angles we're looking for are from negative 90 all the way up to 90 degrees. When we write these inequalities, we definitely want to have that lower value on the left-hand side and the higher value on the right. Turns out that the tangent is very similar to the, oops, I should have drawn that on the coordinate plane here, pardon me. So those will be our inverse sine values. Okay. Oops, and in radians, my fault again. Holy cow. Negative pi over 2 is less than theta less than pi over 2. Okay, I think we're good now. Let's talk about the tangent, and the tangent is just the same as the sine. So if we did the inverse tangent, of course denoted oops, that's going to be the arctan over here. And we looked at the principal values here. Anywhere in the first quadrant, we're taking y over x, and so those are positive. Here in the second quadrant, those values will be negative, back to positive and back to negative, and we've just decided as a group of human beings that we will do this, that the inverse tangent will be the same as the inverse sine. So the principal values there are negative 90 less than or equal to theta up to 90, and of course in radian measure we're going to have negative pi over 2, hope you guys can see that there on the screen, and then positive pi over 2. So that's it, principal values for trigonometric functions. We're just trying to restrict the angle measures so that we don't have repeated values, and these are the ones that we've agreed on.